Hello boys and girls, this is Mr. Kizik, and in this video we're going to be looking at the triangle inequality theorem. So what is the triangle inequality theorem? Well, it says this. It says the sum of any two sides of a triangle must be greater than the third side. So in other words, if I take two on each side of the triangle, and if I add them together, they should be bigger than that other side. Now, normally what you'd have to do, right, is you'd have to check each one. But the one you really only have to check is, well, adding the two smaller sides together, right? Because if I already have a big side here and I'm already adding it with something else, it's already going to be bigger than that smaller side. So let's look at number one. 8, 17, and 24. Can these three sides be a triangle? So, in order to figure that out, what you would really have to do is you would have to see, is 8 plus 17, is that bigger than 24? Is 8 plus 24 bigger than 17? Is 17 plus 24 bigger than 8? But like I said, if I just take the two smaller sides and add them together, that's what I really only care about, because the other parts should be true. So, this is obviously true, that's obviously true. Is 8 plus 17 and 24? Yeah, it's 25. So yes, these three sides can be a triangle. How about number two? So let's take the two smaller sides, add them together. Is that a true equality? And the answer is no. 3 plus 3 is 6, which is not bigger than 7. So therefore, no, that can't be a triangle. How about 25, 35, and 12? So you're going to say, is 25 plus 12 bigger than 35? Yes, it is. It's 37. So yes, that is a triangle here. Let's look at number 5. Is 22 plus 28 bigger than 50? And the answer is no, it's equal to it. But remember, the theorem says that must be greater than, so therefore, not a triangle. So that's how you can determine, given any three sides, any three lengths, we can determine if it makes a triangle or not. Well, how if I gave two sides of a possible triangle, and I asked you what's the range of the possible third side? Well, with this here, there's two possibilities. We know that the two sides given have to be bigger than the side that's missing here. So if I add this together, 14 plus 22, that gives me 26. I'm sorry, wow. That's 26. 36. Bigger than x. So that means my side has to be less than 36. Well, how can I figure out what it has to be at least? Well, let's assume that 22 is the big side. So 14 plus x, that has to be bigger than 22. And then I solve my inequality. I get, yes, and I'm going to go into number 10 here. X is bigger than 8. So my final answer is that my side has to be bigger than 8 or smaller than 30. Notice what we really only have to do here. If you want a little shortcut, AXB, all you have to do is, given the two sides, subtract them. That would be this number. Given the two sides, add them, and that would be that number. So if I do number 11, if you're given the sides 3 and 11, well, let's subtract them. What's 11 minus 3? 8. add them. 11 plus 3, 14. So my side has to be between 8 and 14. Let's just do another one. Number 13, 24 and 7. Well, if I subtract them, I get 17. And if I add them, I get 31. So that, ladies and gentlemen, is how you can determine if 3 lengths can form a triangle and how you can figure out what the possible range is of your third side. Moving right along here, something called the Hinge theorem and the converse of the Hinge theorem. Basically, what says this? So, ordering angles. Let's say I was given 3 sides of a triangle, like in this case here. Well, the smallest angle is always opposite the smallest side, and the largest angle is always opposite the biggest side. Well, let's order the angles from least to greatest here. So, if I'm ordering the angles from least to greatest, well, what's the smallest side here? 7. And what's the angle that's opposite? A. Well, what's the next biggest side? AB, 10. So therefore, the next angle is C. How about if the next biggest side is AC, 13? So the big angle here is B. Well, the converse is also true. The sides of a triangle can be put in order by comparing the angles. The shortest side is always opposite the smallest angle. And the longest side is always opposite the largest angle. Now, notice this example here, they're missing an angle. That's fine, because we know how to figure out the missing angles in a triangle, because we know triangles add up to what? That's right, 180. So I would do 42 plus 103, and then subtract that from 180, and I get 35. So let's see, it wants us to put in order least to greatest. So what's the smallest angle? 35. So the small side would be ED. Next biggest angle is 42, so the next big side is DF. And then the biggest angle is D, so therefore the biggest side is EF. Both these things make sense, because when you think about it here, if I think about like open a door here, if I open the door wider, the distance between the edge of the door and the doorway would be bigger than if I had the door just a little bit open. And that's kind of the visual way of looking at it here. So let's just get a couple examples here, maybe 1 or 2. So number 1 says order the angles from least to greatest. Well, least to greatest, that means I go from the smallest side to biggest side. Here's the smallest side. Therefore the opposite angle is M. Next biggest side is 20, so the next biggest angle is P. And then the biggest side is P, so the biggest angle is N. And let's skip down to number 5 here. So I got 31, 57 are my angles, and so therefore I need to figure out the other angle. So do 180 minus 31 minus 57, and I get this is 90. The smallest angle here is J, so the opposite side would be KO. Next biggest angle is L, so the opposite side is JK. And the biggest angle is K, so the opposite side would be JL. With these problems here, there's really not too much difficulty with it. Where students get it incorrect is just not reading directions. Like for set 4, number 7 here, greatest to least. So you would start with the biggest side first and then go to the small side. And that is it, ladies and gentlemen, with the triangle inequality theorem. So please check Google Classroom to see what the homework is. Remember, if you ever have any questions or concerns, please feel free to message me. This is Mr. Kiesik, signing off.